Okay, so let's divide some polynomials. So for the warm-up, when we do our division, we would put 11 on the outside, we would do our division symbol, we would write 432. So we want to figure out how many times 11 goes into 43, and that would be 3 times. And we do 3 times 11 is 33, and we would subtract, we would bring down that 2. So we'd say how many times does 11 go into 122? And 11 goes into 122 9 times, and we would multiply 9 times 11 is 99, and then we subtract, and we'd have a remainder of 4. So we're going to do a similar thing with long division, but instead of having our whole numbers here, we're going to do it with polynomials. When we did our synthetic substitution, we would have to have placeholders for all the terms missing, like x to the 4th cubed squared, and x terms are all missing in here. So when we do our long division, we have to put placeholders in. So we have x plus 1 is going to go on the outside, and then underneath is our polynomial with all of our placeholders. So I'm going to go ahead and write that in. Okay, so I wrote it out with all of my placeholders. So for this, what we do is we look at our first term x. X times what number is x to the 5th? And that number is x to the 4th. And I'm going to make an x to the 4th column here. Now I'm going to take my x to the 4th and I'm going to multiply by both of these terms. So x to the 4th times x is x to the 5th, and then times it by 1, and you get x to the 4th. And then just like what we did before is we subtract. So I'm going to change all of my signs to subtraction. The first terms cancel out, and I have negative x to the 4th, and just like the other way we did in the warm-up, we bring down our 0x cubed. X times what number is negative x to the 4th, and that's negative x cubed. So when I multiply negative x cubed by x, I get negative x to the 4th. And I multiply negative x cubed by 1, which gives you negative x cubed. Now I'm going to subtract, so that means I'm going to change all of my signs. First term drops down. Here I have x to the cubed. And I bring down my next term, which is 0x squared. So x times what number is x cubed? And that's x squared. So I multiply x squared by x. Gives me x cubed. X squared times 1 is x squared. I'm going to subtract, so I change all of my signs. The first terms drop out. The second ones I have negative x squared. I bring down my next term, which is 0x. X times negative x gives me my negative x squared. And I multiply, oops, it should just be negative x. I multiply negative x by both of my terms, so I get negative x squared. And negative x times 1 is negative x. I'm going to subtract, so I change my signs. Those terms cancel out. This gives me positive 1x, and I bring down my 1 for my last term here. X times 1 gives me x. And I multiply this by both terms. I have x plus 1, because 1 times x and 1 times 1. Then I'm going to subtract, and I get a remainder of 0, which means that these two are both evenly divisible into my polynomial. Okay, so the way we know that something is a factor is if it divides evenly, so that the remainder is 0. So in this first problem, I determined that x plus 1 is a factor of the polynomial x to the 5th plus 1 because I had a remainder of 0. Okay, so again, I'm going to take my x minus 3, put it on the outside, and my polynomial here, and I have one term missing, so I have to have a plus 0. So I'm going to go ahead and write that in. Okay, so now that I've written it out with my placeholder, I can go ahead and do my division. So I want to know x times what number is 9x cubed, and that's 9x squared. So when I multiply 9x squared by x, I get 9x cubed. And I'm going to do 9x squared times negative 3, which is negative 27x squared. And then I subtract, so I change my signs. First terms drop out. The second term gives me 7 plus 5 is 12x squared. Bring down my 4x. And I say x times what gives me 12x squared. And that's just 12x. Now I'm going to multiply 12x by both of those terms. 12x times x is 12x squared. 12x times negative 3 is negative 36x. And I'm going to subtract, so I'm going to change my signs. First terms drop out. Second terms I get 40x, and I'm going to bring down my last term, which is plus 0. X times 40 gives me 40x squared. or sorry, 40x. 40 times x is 40x. 40 times negative 3 is negative 120. I'm going to subtract, so I change all my signs and I get a remainder of 120. So my remainder is 120, so it does not divide evenly in. So I would say that x minus 3 is not a factor of my 9x cubed minus 15x squared plus 4x. Okay, let's do the next one. Okay, so for this one we're going to use synthetic division. So we do our little box. We put our polynomial in there. Remember, if we're missing any terms, we need to have a placeholder of 0. We're not missing any terms here, so I just put all my polynomials in. This here, x plus 1, is my factor, and my root, or my x-intercept, or my solution, is going to be x equals negative 1. And it's the negative 1 that goes on the outside. Okay, so I'm going to do a negative 1, and I bring down my 1. I'm going to multiply to get negative 1, add straight down, multiply 2 times negative 1, which is negative 2, add straight down, multiply 1 times negative 1, which is negative 1, add straight down, multiply 3 times negative 1, which is negative 3, add straight down, you get a 0. Since I have that, I have a remainder of 0, we would say that x plus 1 is a factor of our x to the 4th plus 3x cubed plus 3x squared plus 4x plus 3. For b, it says to use synthetic division, so we're going to do the same thing with the given factor is x minus 7, so the x-intercept is x equals 7, so I'm going to plug in 7 on the outside of my polynomial. I have my 1 from x cubed, there's no x squared term, so I'm going to have a 0. I have negative 57, and then I have a 56. So I'm going to do synthetic division until I get down to my remainder. But this one says I'm going to factor it. So if this here was my function, my f of x, I'm going to write it in factored form. It equals x minus 7 is one factor, and it's times something else. And it's going to be what I get here for my polynomial. It's going to go here, and it's going to be a quadratic, and then I'll factor that quadratic further. So let's start by dividing x minus 7 into my polynomial and see what quadratic is left over. Okay, so we do our synthetic division. We bring the 1 down, we multiply, add straight down, multiply 7 times 7 is 49, add straight down, you get negative 8, multiply, you get negative 56, and we get a remainder of 0, which does confirm that x minus 7 is a factor of the polynomial. So when we have these numbers, it came from this polynomial where this is my constant term, this was my x coefficient, my x squared coefficient, my x cubed coefficient. Likewise, this is my constant term, this is my x term, and this is my x squared term. So these numbers correspond to this polynomial. And the factor x minus 7, when I multiply it by this polynomial, I'm going to get this polynomial that we started with. So I have partially factored my polynomial, which I'm calling f of x right now, as to x minus 7 times x squared plus 7x minus 8. And this is a quadratic. We can use any of our quadratic techniques for factoring. You can use the box method, or you can just factor by foiling. And I know that those are going to be x squareds to give me my first. And when I have two numbers that multiply to be negative 8 and add to be 7, I know it's positive 8 and negative 1. And when I FOIL that out, I do get that. So this is my f of x, and it is completely factored. Okay, let's move on to the next problem. Okay, so the remainder theorem, I'm going to explain what the remainder theorem says in context of this problem. If you divide a polynomial, so in my case f of x, which has a degree bigger than 1, by x minus a. So I divided my polynomial by x minus 7. My a in this case is 7. So it says the remainder p of a, or p of 7 in this example. P of 7, or f of 7, is whatever the remainder is. It's 0. So if I wanted to find f of 7, I could plug 7 into here, cube it, multiply it by negative 57, and add 56. And when I plug 7 into here and do direct substitution, I'm going to get 0. So the remainder theorem says that you're going to get what your remainder is what you'd get when you directly substitute your number 7 into your function and just plug it in and do your algebra 1. So instead of finding what p of -5 is here, which we can directly substitute it in, the remainder theorem says that we can get the same answer as if we direct substitution, -5 cubed plus 21 times -5 squared minus -5 minus 24. This is going to equal some number. Okay? This method here is called direct substitution. Instead of doing direct substitution, we're told by the remainder theorem that if we do -5 and do our synthetic division, whatever our remainder is will be our answer. So there were no placeholders, so bring down the 4, multiply, add straight down, multiply, add straight down, multiply, add straight down, you get 6. So if I were to directly substitute this in, the number I would get out is 6. So p of -5 is 6. So direct substitution is just an easier way of finding your remainder or your direct substitution plug-in value. Okay, that is all. Have a great day.